I'm Matt Godbolt.
And I'm Ben Rady.
And this is Two's Complement, a programming podcast. Hey Ben.
Hey Matt.
How on earth are you?
I'm doing okay. I'm still a little sick.
I was going to say, you sound a bit nasally still.
Yeah, I got a little bit of not really congestion, but just sort of like, I don't know about you, but I feel like at some point in the winter I get a cold. And this was obviously not true in the last 2 years with the pandemic
because
or
you
whatever,
didn't see other humans.
Yeah, right. But at some point in the winter I get a cold, and that cold lasts until spring.
That's been my experience too, right?
Yeah. It's like I feel better, like I'm not really sick, but like that little lingering cough or that little sort of like, rough sound in your throat. It just, the only thing that really cures it is spring, and I don't know. Really
and it's always, you always sound the worst after you've stopped feeling bad. That's what I might discover. So like you feel dreadful for a couple of days, and then you get no sympathy off anybody, and then you sound all stuffy and crap the next day. And it was like, oh, are you all right? I'm like, I feel fine now, actually, but thanks for asking.
Yeah, right, exactly. So yeah, probably a more long-winded answer than you wanted.
That was, question, yeah. This is the Synac of the podcast here. Not the. I'm not actually genuinely interested in how you are, I'm afraid. I mean, I am, but.
Oh man. Yeah. So what are we talking about today?
That's an excellent question. Well, we were chatting yesterday at breakfast, such as it was. We'd got a coffee together as we'd kind of got on the same train, and then we got talking as we do. And then the conversation was so interesting that instead of going to our desks once we actually got to work, we sat down, still wearing our coats, and carried on the conversation about integration testing of all the things. I mean, it seems unlike us to be so excited about something that many people might consider very dull, but maybe not our listener who is now going,
we have this podcast.
Testing? Amazing. Tell me more.
Right. It's kind of shocking to me. I was looking back over some of the old episodes, and it's kind of shocking to me that we haven't talked about this, the best I can tell. I mean, we've definitely talked about shades of it, but
we talked about acceptance testing, which to me I sort of broadly think of as an integration test of a sort. I mean, it is pretty much an end-to-end test type thing, and that's obviously has its place, but not sort of like the integration test that we know and love, or I've written before now, where
right.
often come to regret latterly.
So I mean, basically, as we were kind of talking about yesterday, as you said, integration tests are I think a bit of a double-edged sword. And one of the things that has stuck with me for a very long time is a talk that J.B. Rainsberger gave a few times in a few different venues. I think he was mostly giving this talk back in like 2008, 2009, and I think he's updated it and revised it a few times since then. But the original title of the talk was "Integration Tests Are a Scam." And the point that he makes, and he has, I think he's revised this over time. I think he's changed it slightly as like integrated tests are a scam, and he's got some, some sort of caveats. It's a very sort of clickbaity,
of course, in this world,
title, but it makes you think. And I think the central point is sort of bang on, which is integration tests, which we're going to define as tests that exercise large chunks of the system, perhaps spin up external dependencies like a database or, some other sort of like network service. If you had like if your system was built out of microservices, you might spin up like a whole bunch of containers to run all your different microservices and have them all interacting with each other. Anything that talks to like a third-party service. That's kind of what we're defining as an integration test here. And usually in those kinds of tests, you're testing lots of different pieces of behavior all at once. An example of this would be like, all right, I'm gonna log in as a user, and I want to test to make sure that we can log in. It seems like a reasonable test, right? Make sure users can log into our system.
Certainly very important.
Yeah, so I'm going to start up the web server. I'm going to start up a database. I'm going to populate that database with some user records. I'm going to, go to the website. I'm going to enter in a value for the username. I'm going to enter in a value for the password. I'm going to hit the login button, and then I'm going to get redirected to a dashboard, a user dashboard, and I'm going to confirm that all of that works for some definition of confirm and some definition of works, right? And so those are the kind of tests that we're talking about here. Those are the kind of tests that I think JB was talking about in his talk. And his central point was those tests are a scam. They seem like a good idea. They seem like they give you like a little bit of a safety net and some confidence that things work. And they do, but the costs of those kinds of tests are very subtle sometimes. They can be very hidden, and they are often paid in the future with a ton of interest. And so if you build your system with the idea that you're going to test everything through integration tests, what you often find is that over time, your test suite gets very slow and it gets very brittle and it becomes extremely difficult to make changes to your system, which was kind of the whole point of writing tests in the first place, is that you want to be able to make changes to your system quickly and have confidence that you haven't broken anything.
Yep.
And it's like, well, you still maybe have the confidence that you haven't broken anything, but you can no longer make changes to your system quickly, right?
Yep. Yeah.
And so that is why integration tests are a scam.
Are
and
a
that
scam.
and that idea has kind of stuck with me for a long time. And so a natural question that one would ask, if you say, okay, Ben, let's take that as a premise, is what should I do instead?
Yeah, what? Should I just accept that occasionally I'm going to make an innocuous change and then everyone can't log in and that's okay? I mean,
exactly.
Maybe it's okay if you're Twitter.
Oh.
Too soon, except not too soon, because by the time this goes out, that no one will remember why that's funny.
Sick burn. Yeah, that's true. That's a good point. But yeah, so and that is sort of what we were talking about yesterday. Is sort of like, okay, well, if you're not going to do that,
what are you going to do then? How can I develop confidence that I can make changes and I haven't like painted myself into a corner where in order to make those changes, I have to like update the integration test because I've moved the login box up a little bit, and that was totally not the point of my change. That kind of stuff. So what do I do? Tell me.
Yeah. Well, I was going to ask you some of the things that you've done. Obviously, I've done a lot of things on this, but if you want to throw some ideas out there, I was
playing the foil. Go on, you ask me. All right, that's I don't want to. So like, we were talking about this yesterday, which is not a good thing to keep bringing up on the podcast because nobody was there yesterday, which is why we're recording this today. Yeah. But we talked a lot about transitivity of tests in terms of unit tests in a lot of places. So let's take your logging, for example. So we have tests that say, does our interaction with a database work? Can I select rows out of a database and read them back in again? Okay, that could be a test. Now that does sound integration-y, and maybe it is integration-y, but like I developed some amount of confidence that I can talk to a database. That could be a first step. And then I go, well, now I understand how databases work. I'm going to just get rid of the database and replace it with some kind of fake or a stub or a mock or insert your favorite, not a real thing in technology here. And then I can write the majority, the lion's share of my can I access, quote, the database correctly tests using tests written against that fake stub, mock, blah, whatever. And now I know I'm pretty confident that I can get the user information out and maybe their sorted password, whatever it is. And then I can separately write tests that take a username and a sorted password and say, is this the right user? Is this the right credentials for this user? Tell me yes, no, right? If that's how you're writing your system, obviously. And now I have a sort of transitive relationship where it's like, well, given that I trust the database code, given that I interact with the database code correctly, given that my login system works with canned examples that I've set up, and given that I've tested the interactions between those two using mocks or fakes, now transitively, I don't necessarily have to write the code that goes to the database and checks I can log into the database directly now. I just know the pieces work and the bits between them work. And then I can keep building back and back and back until I get to the point where I have 99.9% confidence in each of the individual steps along the way, handing off correctly, all the way to the web service handler or the JavaScript code that's like, when they click the login, I send this post request, and I know that will get to the endpoint because I have tests there, and it follows all the way through to the point where I go, yes, the user is logged in. And then, now, what am I giving up in that? Well, you can always come up with Machiavellian reasons why that you can break that, right? And that's fair. That's a fair.
Yeah.
But the marginal cost of dealing with the Machiavellian case compared to like the integration test cost, which is giant and, as you say, brittle and often fragile and flaky. I'm definitely like, it's definitely not as certain, because for each step I'm only 99.9% sure, let's say, and so you're multiplying a bunch of 99.9s together, and maybe there's 20 of them, and that quickly becomes like 97% rather than whatever. My maths is not perfect here, but you know what I mean, right? You do lose something. I'm not going to question it, but the chances of a real bug falling in that 3% crack seem diminishingly small to me, and the cost for a big integration test, or at least developing all your tests as integration tests. Now, maybe there's a call that says like, it is so fundamentally and critically important that users can log in that you do have a once a day CI thing that stands up the system and does the thing, or pre-deploy, or even you have a human do it, right? I prefer not to do that, but like, if you need it, then there's a business case for it. But if you build a system where that's the primary thing the primary way you make your tests, then you are definitely making it hard for yourself, right? You can't iterate as quickly, and it's so that I think I went all the way to the far end of the the reply.
No, that's really good. I think that's a really good baseline, because I think that describes the sort of basic answer, the short answer to, okay, if I'm not going to do integration tests, what I'm going to do? Well, I'm going to break the problem down into lots of little bits, and I'm going to use the transitive property to make sure that all of these little bits can talk to each other. And each of those tests for each of those little bits can run super fast and be very reliable, because they're not, necessarily talking to external systems or anything like that. And when they fail, they will give you a very focused answer of, this bit is broken.
Right.
It's not like, well, something in the login process is broken and I don't know what it is.
Let's say somebody changes the crypt method. We pull in a new library, it's got a different version of crypt, and it's not quite compatible. And now users can't log in. And what your integration test says is login failed. And you're like, why? Why is login failed? And then you have to git bisect to find the change, or look through all the PRs, whatever. Whereas if your test is, I couldn't authenticate this user with this password.
Right.
Now maybe you've got a much more localized understanding of where the problem will lie.
Yes. And I think that that sort of difference has a number of very interesting properties to it. One is, it's sort of the difference between if you're doing any kind of data validation, like checking individual fields versus checking like a checksum or a cryptographic shell. Right? Like, if you just take a whole bunch of data and you're trying to be like, what are the differences between these two pieces of data? Well, if you run it through diff, if it's text data, you can see the differences, right? Like, oh, this line is here and it's not there. If you take both of them and you do an MD5 sum on them and you compare the MD5 sum, it's like, well, these sums are different. And it's like, well, what happened? Now, it's much easier to compare the MD5 sums. It requires no understanding of the data itself. You don't have to look at it. You don't have to understand what it is, what each of the individual lines are. It's very simple, but all you really get out of that is, if everything works properly, you knew that everything worked properly.
Right.
If anything breaks, you're left in this world of like, well, I know it doesn't work, but I have no idea why. And so I think that is why, again, creating the bulk of your tests using this sort of integration style will lead to a world in which you will operate very slowly. You will be able to make changes very slowly, because you will be constantly in this world of, hey, these two MD5 sums are different and I don't understand why.
Yeah.
And so there's that property to it. The other thing that I think that it does that's kind of interesting is, it does put a bit of the alternative that we're proposing here, where you break things up into small pieces and test them, does put more of a burden on software engineers who are changing the system, right? And the burden that it puts on them is that they have to make an effort to understand when they're making a change, the parts of the system that interact with that part, right? Which is not strictly true if you say, well, I'm just going to test everything through integration tests because I can lean on the integration test to tell me that, right?
Right.
If I go and I make a change to a system, I can just ignore everything that it talks to and everything that talks to it, and I can trust, quote unquote,
Yep.
that the integration tests will catch that. Now, in practice, I will tell you that any integration test suite that is actually comprehensive enough to test every part of a system using that approach will finish after the heat death of the universe because the combinatorial explosion
Right.
of all of the different possible code paths through all of the different possible conditionals in that system are
Is
just
too immense. I think
it's
that's
like
an interesting
grains of sand in the universe.
An interesting
right?
observation that I'd never really considered is that you are definitely reducing the dimensionality of the problem by testing unit by unit. Like
Mm-hmm.
I'm testing my password hashing thing. Now, of course, there's an almost infinite number of inputs to my my password
Mm-hmm.
hashing thing, and there's essentially 64 bits, 128 bits, whatever of possible outputs, right? And I can't write tests. I
Mm-hmm.
knowingly can't write tests that cover all that. But as I'm designing that thing, I know where the bodies are buried, and I can use
Right.
whichever zombies approach to say, what if I give it an empty string? What if I give it a full string? Whatever. And then I've tested it with all of those things, and I'm sure it works in that situation. And now the property that I transit to the outside world is not the high dimensionality of all those possibilities. It's the, did they log in, yes or no? And then that's the one and only thing. That's the one thing that escapes my world. I've separated away all those degrees of freedom from like the rest of the code.
Right. Yeah, absolutely. And I think one of the cool thing is that if you sort of do what we're talking about here, you will arrive at that sort of naturally, and you will be naturally incentivized to sort of make that contract with the outside world as small and as simple as you possibly can. So going back to our sort of database example with the login, right? Like, okay, if I'm going to break these things apart and I'm going to have, some system that interacts with the database to say, hey, I need I need to get the salted password for this user, for example, right? Like the fundamental operation of get me a salted password or get me any field that's related to a user has nothing to do with SQL or databases or, servers or network connections at all. It's a very simple operation, right? And so there are various points in this sort of chain where you can create abstractions that are significantly simpler than the actual underlying system that's backing them.
Right. You could reasonably have said, you could have exposed the SQL to everybody, for example, and then in the first case, because it's convenient. Hey, select star from users where name equals quote whatever I have in my tree. That's one thing. But this forces you down the route that says, no, I want to provide the API of bool does user exist. Bool does user is check password or whatever. That's obviously terrible. This is not a great way of designing a system for anyone, but like those kinds of things, you're forcing the testability boundary to look more like what the downstream users will actually want, because you don't want to expose them to that, and then you can hide it away from everyone, including yourself, most of the time.
Right. And that has a lot of like really good design benefits that are very practical. They're practical in the sense of like it's helping you write better, faster, more reliable tests. But it also sort of, in my experience, it actually sort of creates a nice sort of framework for discussion among like the people that you're working with. Right. Because like people have these sort of like esoteric, almost like philosophical debates about software design all the time.
Mm-hmm.
And what actually kind of helps that, and I'm sure you've seen this with performance too, what actually kind of helps that is having a constraint, right? Saying like, oh, well, we can't design it that way because it'll be slow, or we can't design it that way because it won't be testable. It actually sort of like helps people come to an agreement and say like, oh yeah, that design is better, and I can see why, right? As opposed no, I want an object hierarchy here. It's no, we should use functions. It's no, we should use a list. No, we should use a set, whatever. And it's like, if you can tie that back to something concrete that everyone agrees is valuable, of course, then you can actually have like much faster, more coherent, more aligned discussions around software design because they're based on fundamental principles that you all share, right?
Yeah.
And you don't get the opportunity to do that if you don't create the constraint by saying, well, we can use whatever design we want because we're just going to create this with an integration test anyway.
Yeah.
Right? or we're just going to test this with an integration test anyway. So it doesn't matter if you create a nice layer of abstraction over the database. You can just have the templated string with the SQL in it and, inject whatever values you directly got from the UI into that
Terrifying.
string. Cringe, cringe,
I
cringe.
can't even...
because that's not going to, that's actually the easier thing for you to do, as opposed to the easier thing being creating a nice abstraction that you can then swap out, right? And this actually leads me to another thing that we were kind of talking about, which is a technique that I do all the time, which is using the sort of test fakes that you create as part of doing this process as sort of the repository for institutional knowledge about strange errors.
Right.
So like you build your interface to your data store, right?
Right.
And
there were air quotes for the listeners there around the data store.
And it's a database under the covers. The normal implementation is a database, right? Some thin wrapper around some SQL driver or something like that you have. And maybe you even think about it as like a SQL-based thing, right? So it's like I'm giving this thing SQL statements and it's giving me results. I don't really understand what's going on behind that abstraction, but that's what's happening.
Yeah.
Like, that's the interface that I have, right? And you have your sort of real, okay, we're using Postgres, so we use the Postgres one. And then maybe there's like some, some really stupid stub that you create, maybe, where you just have like hard-coded query strings with hard-coded responses, and you can use that in some of your unit tests when you're just testing things like,
right.
That's not the point of this test. It's not to test if the database works or if SQL's correct or anything like that. I just want to make sure when I run this query and I get this result, do I process it correctly?
Yeah,
right?
yeah, which is a very common thing to want to do, right? Yeah.
Exactly. But another form of implementation that you might have there, in addition to the real one and in addition to the super dumb fake one, is a realistic one that lets you simulate error or failure modes, right? And this is something that, like, a lot of times you will have some strange esoteric error. Like, oh yeah, the cluster was rebalancing, and in the middle of the rebalancing, we executed this query, and there was some sort of weird, data partitioning condition that the database detected, and it threw this error that we'd never seen before, right? And we have no way to reproduce it because it just depends on like the timing of the database, like actually just doing its rebalancing.
But we want to lock in the good behavior of, if we see that again, because we fell over in prod.
Exactly. It created, So like, where does that knowledge go, right? Well, in a lot of organizations, it just goes into a ticket or a document, and that's where it is, right? But there's an alternative here, which is you can take that hard-won, hard-fought knowledge where somebody had to wake up at 2 a.m. to deal with this thing, and take it and encode it into a sort of a test double, like a fake database, whose purpose is to kind of mostly behave like a real database, except it lets you puppeteer all of the different failure modes that you've seen.
Yep.
So when you go and you write that code to say like, hey, we have this 1 in a million error condition that only ever happened one time, and that happened 12 months ago, and I'm changing the error handling code for that right now because we're making another change. How do I know if this error handling code actually still works?
In that weird case, yeah.
In that one weird case, right? Well, if you encode that information into your test doubles, you can have a lot of confidence that it works, right? Because you can say like, yeah, well, we reproduced the error that we got in the client code by re-raising that same weird error that we saw out of the database. The client code failed in the same way, so we knew that we sort of reproduced it. And then we fixed the client code so that it handled that error, so that it wasn't an issue. And we have a test, that makes sure that like when that client code runs and this error occurs, it works. So I can go back later and I can say, okay, well, if I change how that's handled or I handle it in a different component, I can reuse that same fake database in a completely different component. It's like, oh yeah, when you're interacting with the storage system,
you have to know.
Watch out for that.
Sometimes it'll return error. Yeah.
Because it can happen sometimes, and you can have a reasonable degree of confidence that if it happens again, you will handle it, right? So there is another sort of opportunity that you get by using this approach to sort of encode that information in a way that is much more immediate than tucked away in a ticket somewhere that no one will ever look at again unless something goes terribly wrong.
At the very least, the fake stuff, I can see that it could work, but I, in my experience, when those things have happened, definitely setting out and like making a mock that walks the system through that
Mm-hmm.
exact system, exact set of circumstances, and then giving a test the name that explains it and maybe has the reference to the ticket where it was filed or the PagerDuty alert or whatever,
Mm-hmm.
is a great
Mm-hmm.
way of saying, like, here is the pile of wounds that we've recovered from, and here is our list
Yeah.
of.
Yeah.
I think you said institutional knowledge, right? When
Mm-hmm.
when the greybeards go, oh, you probably hit that thing, then
Yeah.
you're
Right.
going to go, well, how was I supposed to know that? You're like, well, if you'd have written a system for which the test fell out naturally, then maybe you would have found it, or maybe it would have been more obvious. And certainly, refactoring the code later to not handle that will be picked up, and you'll be reminded that
Right.
yeah. By the way, your new code, the new error handler doesn't handle the strange network split that we saw.
Mm-hmm. Mm-hmm. And if all of your if you just have a big suite of integration tests that are all talking to a real database, then you can't really write those kinds of tests. Like you can, they're just very expensive to write. They're going to be
And in
very
some cases,
one-off, and
they're
they
almost impossible to puppeteer the system into a set
yeah,
situation where you can
exactly,
make it
exactly.
happen even remotely or at all. Like some strange admin commands, and nobody wants to have any chance at all that like these unusual things where you're like maybe even killing processes to try and kind of make it do the error.
Right,
No, that's not
right.
code you want to write in case it ever
Yes,
somehow makes it remotely near production, right? That's the
right, right. Yeah, exactly. And then you wind up doing it. It's like very, very expensive to write those tests and run them and make sure that they work. And it's for this error that has only ever happened once.
yeah,
And you start asking yourself, like, yeah, we added like 2 minutes to our build to like
handle
bring up
this.
this database and tease it into a state where it produced this error and then crash and then do the thing.
Yeah, that's not
This
good, and it's
this error only ever
flaky
happened one
anyway. Yeah,
time,
it just
right?
doesn't
And
seem
it
like so.
doesn't always work.
You
Yeah,
could easily argue for like, well, let's just cross our fingers and hope it doesn't happen again, which isn't a satisfying answer compared
yeah,
to here's a 15
exactly.
line test that sets up the fake in the right way and calls the login
Right.
method and says, yep, look, even if we get a split during the login, we just retry.
Yep.
Done.
Yep. Exactly. Exactly. So I think that there are a lot of benefits in addition to the I think sort of more immediate benefits of the tests run faster and they're more reliable. There's a lot of like design benefits to saying like, okay, we're gonna decompose our system in this way. We're gonna be able to test it in this way. We're going to think about it in this way. There are trade-offs, like I said before. It means that you need to think a little bit more about the interactions with components when you're changing them. You have to have a sort of a wider view on the system.
Right.
But I think that those trade-offs are very worth it.
Yeah, I agree. So
Mm.
there's another sort of aspect to quote integration tests that is something that certainly I've done, and I know other people do as well, and that is like sometimes you don't know how a third party API, a third party
Mm.
server, how it works, right? And so you want to kind of write
Yeah, yeah,
tests
yeah.
in the same way that I write test to test code that I might be interacting with, kind of exploratorily, even if it's my own code, TDD style, like, hey, I wonder what happens if we pass in this string to my code.
Mm-hmm.
The way that I reach to do that is to write a test that does it, even if it's just called test foo and it doesn't, I'm never going to use that test again, right? And I'm not even going to check it in. Like, it's a great way of interacting with your own code to be able to say, like, I just want to run this bit of code. But so it seems natural to reach for testing for the same kind of exploratory testing with a real environment, because maybe you don't know what happens under these circumstances. How
Yeah, absolutely. There's a real power in writing tests that you intend not to keep, right? I sometimes refer to this, and you've heard this before, as make it till you fake it instead of fake it till you make it,
yeah,
right? So you can write tests against a real system, and this, like I've definitely done a thing where it's like, all right, I'm going to get some read-only credentials to this database. It might even be a production database because it's got some data in it that is interesting to me, but I've got some read-only credentials. I'm confident that they're read-only credentials, and I'm going to temporarily put those credentials just hardwired into my test because I don't know how this particular API works. I've never used it before. I don't know how it works. I don't know how it breaks.
yep.
I don't know what
What does the
the
error message
various.
actually look like?
Yeah, exactly, exactly. And so, and I will sit down and I will write tests to sort of explore that, knowing that I'm going to either dramatically change these tests before I actually go and check it in, or I'm just going to delete them, right? And that can be really useful, especially if you have a setup where your tests run automatically. It almost becomes kind of like a REPL, where you can just be typing it away in a test and be like, oh, what does this thing do? I'm going to assert that the return value of this, get user count is null. It should always be an integer, right? And
Right.
then I see, oh, yeah, it's 105 in the production database. Cool. What if I point it at a table that doesn't exist? Oh, shit, it's null. It should never be null.
Yeah.
But in this case, it is actually null, right?
Yeah.
So that kind of like exploration can be a great way when you're in that stage where we're trying to figure out how to break this thing apart, right? Because again, one of the things that you get from this, one of the trade-offs from this approach is you do actually have to think about the design of this and how do I create these like easily testable seams. That's not always obvious when you're first, using an API or thinking about a problem.
Right.
Like you have to sort of come up with that. That's your job, right? So having sort of like everything just sort of laid out in front of you in a messy way that doesn't try to do this so that you can see it all and you can interact with it all, you can understand like how the system works, and then say like, okay, I think that if I built a little abstraction around this part, I could basically treat it like, let's say, for example, a sequence, right? So I just have a sequence of lines that is coming out of this thing. I don't really know what it is, but I can create an abstraction on top of this API that will basically treat it like that. And then I can build my real implementation under that. And all it does is produce a sequence of lines.
Mm-hmm.
And then, lots of things are great at producing like a sequence of lines, like a list of lines. So I can use that as my test double. And I can start designing, basically doing the design work to tease this apart and say, okay, the code that I have that operates on a sequence of lines, super easy to test. I can pass in whatever I want there. The API that I now know how it works, I can model as a sequence of lines. And so the wrapper around that is extraordinarily simple. And then I can do some additional things where I, kind of like we were saying before, maybe I write an integration test for that real implementation. Maybe what I do is I just get really heavy into mocks and I actually just like mock out the interaction with the API. That's another approach. You can sort of do either way. Maybe what I do is something I do a lot is rather than having an integration test, I test for integration. So when my
right.
system starts up, I say, I'm going to take all of my objects that I'm instantiating that represent real world systems that I didn't want to write unit tests for because they would be slow and unreliable. And I'm going to make sure that they work at the point when the system starts up so that it will fail fast if they don't. So in the case of the database, I'm going to make sure that I can connect to the database. I'm going to make sure that my credentials are good. I'm going to make sure that the tables exist. I'm going to make sure that the tables have the schemas I expect.
Yeah.
And if all of that stuff is not true when the system starts up, it doesn't really matter what's going to happen after that because nothing else is going to work.
Nothing
so
will
it's
work.
just going to shut down and be like, hey, I expected there to be this table and it doesn't exist. So sorry, I can't do anything. And I think that is a much more sort of practical way to get confidence that those external dependencies really work the way that you do. Because you tend to build them up in this sort of iterative form where like at the moment when you're writing the code, you're pretty confident that it works. You've done your make it till you fake it, or you've written a little, command line test driver program to make sure that it works, or you've, stepped through with the debugger and you've made sure that it works. It's like, all right, I'm pretty confident this works. But the thing that you have no control over is the outside world,
Yes.
right? Did the configuration of the database change? Did the schema change? Did other things change? And so you can try to test for those things in an integration test that runs in your CI, but that test is going to be unreliable. And it might be unreliable in a very unfortunate way, which is if you introduce a bug that causes a problem with the database and it's critical, you have to fix this right now, you may wind up in a situation where it's like, oh yeah, we fucked up the database and I need to go change this code in order to fix it. But I can't deploy that code because it depends on a continuous deployment system that actually checks the real database,
right.
which is not working.
Which is not working, right. And then you're
so
like, can't
you wind
even
up
deploy.
having to be like, yeah. So you wind up having to do this thing like in a panic, like turning tests off, which is like, okay, everything's on fire. You're panicking. You're turning off all the safeties. Like that doesn't seem like a good idea, right?
Bad
like that's
situation
exactly
to be in.
when you. That's the very moment when you need those tests to give you the confidence that you can just very quickly get a production fix out there and not have broken
That's an
anything
interesting
else,
observation.
right?
Yeah, I hadn't thought about that.
Yeah. So that kind of style,
Yeah.
I think, where you're testing your external dependencies at the sort of the last responsible moment, at the moment when you know, okay, this has to work now. It's kind of okay if it wasn't working before, but it has to work now. Um, that kind of thing can be, I think a better way. And then you can write those tests to be very focused, right? It's not this sort of general like, oh, do databases work at all?
Right.
Can I execute every possible query because my interface here is like, well, this is a general query interface, so I should test all these different things. It's like, well, no, you actually don't care about all those different things. All you care about is, does this table exist? Does it have this schema? Does it have these types
Right,
in the
these are
column?
preconditions under which I've performed all my other tests. If I can
Yes,
prove those at
exactly.
runtime, now I can transitively believe that the rest of the code should work.
Exactly,
Nice.
exactly, exactly. So I think that's another alternative to sort of the like, okay, I want to write integration tests just to prove that the database is configured correctly. And it's like, okay, yeah, I can see why you'd want to do that. But rather than writing like, a unit test that does that, maybe try a different approach.
Yeah. Well, this has pretty much covered everything that and more that I had in my list below here. So, I mean, I think
Yeah.
we should exhort folks to seriously reconsider any integration testing that they're doing with these kinds of alternatives.
Yeah. Might be a scam.
Might be a scam. You heard it here.
Might be a
I was going to say
scam.
you heard it here first, but no, this is what. How old is that
You heard
talk?
it here at least second, probably like 75th. Yeah, 10 years old at least.
Oh dear. All right. Well, that's how much we've got our finger on the pulse here.
Right. Yeah. Cool.
All right, my friend.
All right.
I'll
Yep.
see you the next time.
Good as always.
You've been listening to Two's Complement, a programming podcast by Ben Rady and Matt Godbolt. Find the show transcripts and notes at www.twoscomplement.org. Contact us on Mastodon. We are at twoscomplement@hachyderm.io. Our theme music is by Inverse Phase. Find out more at inversephase.com.